Hey guys, it's Mr. Lowry. This is some notes and ideas from our day 3 lesson. So if you missed day 3, which would have been Wednesday for A day, Wednesday, February 10th, and for B day, Thursday, February 11th, this is for you. I'll help you get started here with some key ideas, and then we'll jump into the homework as well. The main thing that we need to talk about, or one of the main ideas, is the difference between arc measure and arc length. And they sound like they should be the exact same thing, but they're actually not, which can be a little confusing. And so I wanted to point that out to you so that you don't get confused as you go through this homework. Okay, let's start out with arc length for a second, because this is actually what we talked about yesterday, or in day 1, I guess. So arc length is a distance. Okay, if you remember, it was like the length of like a pizza crust. If you were in class, we kind of talked about that analogy. So if this is my pizza, okay, I have a 60-degree central angle, I have a 25-inch radius, the arc length would be this distance right here, the length of that crust, okay, which we're going to come back and do in just a second. But that distance is measured in some kind of unit. So like in this case we have inches, but it could be centimeters, meters, miles, things like that. So that kind of thing. Centimeters, meters, inches. Okay, those are all things that have to do with arc length. Another thing is how to find the arc length. Okay, the arc length formula is arc length, and they actually use L for this in the book. L for arc length is equal to, you got to find the fraction, so it's like the central angle over 360. Okay, that's how much of the circle you're talking about, and then you multiply that by the circumference of the circle, 2 pi r, something like that. Okay, so for this guy here, if we wanted to find arc length, we would use that idea. So the arc length, L, is what they use in the book. It's equal to 60 over 360, right? This is the 60 degrees. Let me zoom in a little bit. Is the central angle. The whole circle is 360, so this is part over whole. And then we're going to multiply that by the circumference. And the circumference is 2 times pi times the radius, which in this case is 25. Okay? So this isn't anything new yet. This is all stuff we talked about in day 1. Let's go ahead and finish this out. 60 over 360 is actually just a sixth. That simplifies. And then we have 2 times 25 times pi. So this is like 50 pi over 1. And since 50 and 6 have a common factor of 2, we can simplify this a little bit. 2 goes into 50 25 times, and 2 goes into 6 3 times. Okay, so this is a length measurement in inches. That's what the arc length is. Now if we wanted to change that to a decimal approximation, we could do that. We would just grab our calculator, use our pi key, and as a decimal that looks like it's 26.8-ish inches. Now that's an approximation, not an exact answer, but you know, depending on what we're doing, we may not need an exact answer. Okay, so let's zoom out. Okay, what is arc measure then? Okay, now arc measure is actually a lot easier to find, so we're actually kind of ahead of the game because we already talked about arc length. Let's talk about arc measure. Okay, arc measure is always in degrees, measured in degrees. Okay, sometimes on worksheets or something like that, I'll try to remind you of that by saying arc degree measure, because I know sometimes when you see arc measure and arc length, those things seem very, very similar, but they're not the same thing. Okay, it's measured in degrees, and it actually matches the central angle that defines the arc. Okay, so if you're looking at our circle again, let me zoom in, I should have made this bigger. There's our central angle, 60 degrees. So what is the arc measure? Drum roll, it's 60 degrees. Okay, the arc length is here. If we wanted to find an arc measure, it's the same degree measure as the central angle that defines it. So sometimes you'll see the central angle labeled, sometimes you'll see the arc labeled in degrees like this, and those mean exactly the same thing. Okay? So that's the big, I don't know, that's the distinction, and that can be a little bit confusing. And so I wanted to spend a few minutes talking about that. In this assignment that you're going to be doing, most of the time you're going to be finding arc measures, which are in degrees, but there are a couple questions where you're going to deal with arc length. And we're going to talk about, how these are related a little bit. Obviously this thing relates them, right, because you have central angle, but remember central angle and arc measure are basically the same thing. So you could rewrite this, L equals arc measure over 360, right? And that's the same thing. Central angle, arc measure, and we multiply that by the circumference, and we get the arc length. Okay, so either of those are similar. We'll come back to this and talk about that relationship again because that's really important. All right. The other thing we need to know is kind of how to categorize arcs, because if we take this idea of arc measure, we can actually make categories of arcs based on their measurement. Not their length necessarily, but their degree measurement. Okay, so I'm just going to show you this because this is actually pretty good, better than I could write. This is in your book on page 530. So notice that we have the minor arc, the major arc, and the semicircle. So a minor arc is just any arc that is less than 180 degrees. So notice this guy is 110 degrees, which is less than 180 degrees. So it's a minor arc. Okay. A semicircle here is the measurement is exactly 180 degrees. So whenever you have a diameter, you also have a semicircle, which is like in between a major and minor arc. And then a major arc, of course, is bigger than 60 degrees, or sorry, bigger than 180. So you see that 60 degrees there, and you're like, hey, isn't that a minor arc, not a major arc? Well, they're talking about the red line here. Okay, so this goes all the way around. So we got, less than half the circle, more than half the circle, or exactly half the circle. And this all has to do with angle measure or arc measurement in degrees. Okay. The other thing that you need to know from this is how to name arcs. Okay. If it's a minor arc, you can use 2 letters with the little arc symbol above it. So almost like naming a segment, except it's on a straight line, it's a curvy line. Okay, so this arc you could call AC. With a major arc, you need to do something more than just 2 letters. Okay, let me explain why that is the case. If I called this arc DE instead of DFE, you'd be like, oh, DE connects D to E, right? There's 2 arcs that connect D to E. There's the short one, and then there's the all the way around the long way, right? And most of the time, we're going to take the path of least resistance, and we're going to go the short way. So if you see 2 letters, you're going to connect them the shortest distance possible. When you see 3 letters, okay, I'm not taking the obvious short way around. I'm taking the long way around. So notice that this arc has an F in the middle, DFE. Okay, if it's a major arc, I need a 3rd letter, and I basically have to say go from D to E, but you got to pass through F first. So it tells you which direction to go. Now with semicircles, they have labeled them with 3 letters. You can do 2 or 3. It doesn't really matter. I think in the worksheet that I gave you, I think some of them are labeled with 2 letters or whatever. That just kind of depends on the book that you're dealing with. It's just a convention, but 2 or 3 will get you there. I mean, this arc and this arc, they're both going to be 180 degrees, so it's kind of about the same either way. So those are the naming conventions. And the other thing that's kind of interesting is this, again, we talked about this relationship. So if you look at this right here, this is like our arc length formula basically. L is arc length, and it's equal to the central angle, which is the same as the degree measure of the arc, divided by 360, and then you times by circumference, which you can also write 2 pi r. Okay, so let's compare how it says it in the book with what we wrote right here. Okay, I have it kind of reversed. L on the left, here's L on the right. Okay, arc measure, they use capital A for arc measure. That's okay. Same as the central angle. 360, 360, and then there's C, right? But we know C is 2 pi r. So this right here is essentially the same relationship, the same formula that we talked about on day 1. This is also the same thing, it's just rearranged. Okay, so if I were to like divide both sides of this equation by C, I would get A over 360 on the left, and I would get L over C on the right. But remember that C is the same as 2 pi r. This proportion, though, is actually going to be really helpful for some of the questions on this worksheet. So this is another key idea. We already have this written down. I would write this down right here. Make sure you have that with all of the labels and everything, because this proportion we're going to use to solve for missing pieces. This is really great if you want arc length, but what if you wanted to solve for like a central angle or an arc measure? What if you wanted to solve for r, right? In that case, this proportion would be better. All right, with that, let's jump into the homework and see what we got, okay? So I made a worksheet, and it starts off pretty easy. We're just going to name some arcs, and I'll go through like the odds on this one, I think. So let's take a look at number 1 here. Okay, got angle 4. We just want to name the arc. Okay, that arc's going to be a minor arc, so I don't need 3 letters, I only need 2. So I'm going to call this guy KH, put a little arc over it, and that's it. Now we can also name this HK. You don't really need both, but one of those will do. On number 3, your central angle is this big guy all the way around. And so if I want the arc that goes with that central angle, I'm going to need a major arc. So I can't just call it FD, because remember FD by default means the short way. But I want to go from F to D the long way. And so what I'm going to say is I'm going to say FGD. Right? That's a major arc. It's bigger than 180 degrees. This one's smaller than 180 degrees. So major arcs you got to write with 3 letters. You could also call this guy DGF if you want to go the other way around, but either way, we're taking the long way. Okay? Not really any work to show on this. Typically, I'm going to, insist that you guys show work when you do it, but in this case, we're just naming stuff. Okay? Naming, not really a lot of work to show. All right. Let's go through a couple of these examples here. So here we have some missing arcs or missing angles that we want to find. Okay, we're supposed to find the measure of the arc or angle indicated. We can assume that lines that appear to be diameters are diameters. So like this guy, for example, they look pretty dang straight. We're going to assume that that's going to be a diameter. And then we want to show our work in organized steps. Okay, so here we want CDE, right? One of the things we need to know if we're trying to find missing arcs or measurements or missing angle measurements is that the full circle is 360 degrees. So what I would do here is I would take that full circle measurement, 360 degrees, all the way around, and I would subtract 110 degrees. That's this guy, and that will give me the rest of this stuff. Because I want CDE, that major arc. So 360 minus 110 is going to equal 250 degrees. And that is the measure of the arc we're after. Okay? Now here, let's talk about a couple things really quick. This is 110, right? This is labeling the arc measurement, not the arc length. You can tell because it has a little degree symbol here. Let me zoom in a little bit. So if this arc is 110 degrees, then this angle is 110 degrees, right? Those are the exact same thing. And if we find these angles, then we have these arcs. Okay, same idea. Now this full guy right here, we just found out is 250 degrees, which means that this full angle is 250 degrees. Also in this picture, doesn't really matter to us right now, but notice there's congruence markings. Okay, so if I wanted to find this arc right here, I know that these two are the same arc measurement, which means these are the two same angle measurement. So what I could do, we don't need to in the problem here, but I could divide 250 by 2 and get 125, and so that means this guy's 125 and this guy's 125, which means that this arc measure is 125 degrees and this arc measure is 125 degrees. So I could say that, arc CD, that minor arc, the measure of CD is 125. It doesn't ask for that, obviously, so we're going to stick with the answer that we had. But I wanted to highlight the things that you're going to look for as you're doing this. Okay, so the first piece of information that you need to know is that full circle, do this a little bit, is 360 degrees. Okay, that's a piece of information you're going to use. You're also going to need to look for congruence markings, because those will tell you where you can, set angles equal to each other or divide a bigger angle in half or things like that, kind of like what we did here. So those are two important things. We'll add to that list in just a second. All right, jumping to number 7, we need the measure of angle VXT. So VXT is this angle, right? But we can also find this arc measurement because that's the same thing. So here's a central angle 113. That means the arc, SW, that minor arc, is 113 degrees. That's its measurement. Okay, if this arc measure, the measure of arc TU is 53, then that means this angle is 53, and so on. So we can kind of use those interchangeably. Arc measure and central angle measure are essentially the same thing. Okay, let's see what we got here. We got a couple things to think about. Notice that these are diameters. Okay, whenever we have a diameter, we have a semicircle. Okay, if we have a semicircle, we have 180 degrees. So a couple things we could do is we could look at this diameter, for example, and we could say these two angles form a linear pair because this diameter is a straight line. So 180 minus 113 will give me that guy. So I'm going to show my work here. That's going to give me 67 degrees. Okay, so that's cool. Now notice that I also have a linear pair this way, right? So here's another diameter. Okay, 113 and this guy form a linear pair, so these have to add up to 180 as well. So I could also do the same thing, 180 minus 113 equals 67. So this guy's 67 as well. But hold on just a second. We could have gotten there easily because notice that these two guys, this guy and this guy, are vertical angles. Okay? So vertical angles apply in here as well. If I get this 67 degrees and this guy has to be 67 as well. That only works when you have two diameters though. You only get vertical angles with two diameters. You have to have two straight lines. For example, sometimes people will go like this. Oh, here's 75. 75 must be over here as well. Well, those aren't vertical angles because vertical angles only happen when two straight lines intersect. So they can't just be across from each other. They have to be across from each other and formed by straight lines. Okay, so don't call that 75, don't call that 75. In this case, though, two straight lines intersecting, we get vertical angles. Okay, now what we have here is we want VXT, right, this guy, so we need this one. There's multiple ways to do this. Let's talk about a few different options. Okay, first of all, we have this semicircle. 67 and 53 and this angle together have to form 180, right? So I could use that to find this one. I don't really need the whole thing though. I already know this guy is 67, so I know that 67 plus whatever this full thing is going to equal 180, and that's what I want, right? I want VXT, this full angle. So I'm just going to do 180 degrees minus 67. So our two angles are this guy right here that we're looking at, and then this full angle right here. Those have to add up to 180. Okay, so if I do that, I'm going to get, should be 113, right? Yeah, 113. Okay. Now, you might be like, well, didn't we have that 113 before? We actually did. So if you go back and you look at this here, we have another set of vertical angles, right? We have this full guy and this full guy are vertical angles, right? Now, of course, this angle, VXT, that we're supposed to find, is cut into two smaller angles, but that's okay. The full angle VXT, this guy, is a vertical angle with this WXS. So there's that vertical idea this way as well. And you could just be like, oh, this whole full thing is 113 because it's vertical angles, right? So you could do that as well. It doesn't ask for this, but if we really, really wanted to, we could find this angle, the VXU angle, because these two together have to add to 113. And I know this one's 53. So if I did 113 minus 53 degrees, that's going to give me this angle. I think that's going to be 60. Let me double check that. Yep, 60 degrees. So just this guy right here, just VXU is 60 degrees, so I could put like the 60 right there. So there's lots of ways to go about this. There's not any one way that's right or wrong. You just kind of got to pick and see what you see. So other things that we want to look for, let's add these to our list. Okay, we want to look for diameters and semicircles. Those go together. Because diameters will give you like 180 degrees. They'll give you like linear pairs. And semicircles also will give you 180 degrees. So this is going to tell you, you know, you're getting at some linear pairs here that add to 180, that kind of stuff. Okay. Also, if you have two diameters that cross each other, two straight lines that cross each other, then you're going to find some vertical angles. So this is kind of like your short list of stuff that you want to look for as you're solving these problems. You want to look for, you know, do you have all the angles, and can you add them all up and get, you know, 360 or something like that? Do you have any congruence markings? Do you see any diameters? That's going to give you linear pairs. You know, things that add up to 180 you want to look for as well. Vertical angles, stuff like that. Those are all things that you can kind of look for. Okay, look for those. Okay, now again, I just kind of added this 60 degrees, 60 degrees. We don't really need that, but you know, just to be thorough, just as an example problem. Okay, let's jump to the next page. We'll look at number 9 here. Whoops, sorry, number 9. There we go. We want DCF, which is an angle. So DCF, we want this full angle right here. Kind of draw it in. Notice again that we have two diameters, which means we're going to have vertical angles. Okay. So these two are vertical angles. So this guy's got to be 56, or you could put like, you know, this guy's 56 and this guy's 56. So these two guys are congruent to each other. So that's cool. We also have, you know, a linear pair idea because there's another diameter this way. So you could look at this semicircle here. Right. So here's a diameter. We can add these two angles, or so actually we want DCF. We want this guy. So we can find like this missing angle and then add these two together. There's lots of different ways to go around this. Let's look at this semicircle. So 56, and then we got 59, and we want this guy. Okay, we can just subtract from 180 here. So these angles all together are going to make 180. Okay, I want this one. This is kind of hard to see because I marked it up. We want DCF, right? But I already know that this angle is 59 degrees. So if I just subtract 59 from 180, I'm going to get it. That's going to be 121. Okay. Again, there's lots of ways to get there. We talked about this vertical angle thing. We don't necessarily need to use that. We could actually find this one. Let's find this angle just for fun. Okay. So we know that 56 and 59 and this one, this guy right here, are going to add up to 180. So if I do 180 and I subtract the sum of 59 and 56, then I'll find this ECF angle. So this is not part of the problem, but just for example purposes, we're going to be kind of thorough here and find multiple things. So I'll do 59 plus 56. Okay, so that's 115, and we're going to subtract that from 180. And that's 65. So that means this guy right here has to be 65 degrees so that these three add up to 180, or these three add up to 180, right? let's find this one really quick as well. So notice there's another semicircle. Okay, so if this is 56 degrees, this and this together have to add to 180. So 180 minus 56. So this was a 65. 124. Okay. Again, now it's more than we needed to do, but this is what we're after. This is just kind of bonus, kind of finishing it out. All right, a little bit lower, you have similar kind of idea, but this time we have unknowns, right? We have x's and stuff like that. So we're going to have to set up and solve some equations, and of course we want to show that equation, we want to show those steps. So in this case, what I would notice is that this is a diameter, which means these two arcs or these two angles have to add up to 180 degrees. So 22x plus 6 plus 9 plus 11x, so adding this and this, should give you 180 degrees because together they form a semicircle. You could also say that, you know, these two angles match these two arc measurements, so those have to add up to 180 because we got this linear pair. So those ideas all kind of still make sense. So we have 33x altogether plus 15 equals 180. When we subtract 15 from both sides, we get 33x equals 165. Hopefully that comes out nice. We'll see. All right, it does. X equals 5. Okay, not what we were after, but definitely something that we need. We wanted the measure of VRW. So VRW is this angle, but we know that that angle measurement is the same as this arc measurement. So we're just going to plug x into that expression, and we'll get not only the arc measurement, but its matching central angle. So 9 plus 11 times 5, or 9 plus 55, or 64 degrees. Okay. Let's keep on moving here. Okay. We want to find the measure of CD. That's this minor arc right here. We need x, so we're going to have to set up an equation. When you look at this, though, notice that there are no diameters at all. If there's no diameters, we don't have any vertical angles. We also don't have any linear pairs. So we can't use the 180 idea. We can't use the vertical angles idea. Our only hope here is to use the 360 idea. All the angles of a circle have to add up to a 360, or all the arc measurements have to add up to 360. So remember, if this is 40, then this is 40. And if this is 105, then this is 105. And all these arc measurements have to add to 360. All right, let's set it up. So we got 92 plus x, that's this guy, plus x plus 62, this guy, plus 105, this guy, plus 40, this guy, plus 75, this guy. All together have to give me 360. Okay, so let's put all the x's together. We got 1, 2, just 2. Okay, so 2 x's. Okay, let's get the angles here. I'm going to use my calculator friend for help here because there's a lot of numbers there. 92 plus 62 plus 105 plus 40 plus 75. Okay, so that's going to be 374. And you might be thinking, wait a second, that is more than 360. Well, that's okay. X isn't an angle measurement or an arc measurement. It's just a variable. So that's okay. We're going to subtract 374 from both sides, which will give us 2x equals negative 14. It's okay. Divide both sides by 2, and we're going to get x is equal to negative 7. All right, not what we were after, but we definitely need that because we wanted the measure of this minor arc CD. Okay, so if we plug in that negative 7, we have negative 7 plus 62. That's going to give us 55 degrees. So let's do that. Negative 7 plus 62 equals. So plugging it back in. All right. That's how that one works. Got to apologize because it looks like I didn't give you guys enough space. trying to show my work in organized steps, but I'm running out of room. So do your best there. I know if it's not, perfect, we'll give you a break. But I definitely want to see some work there and see what you're doing. All right, now, sorry, I switched gears. These next ones here, again, there's not a lot of space. That's my bad. I forgot to space these out for you when I wrote them. But we're going to use a key idea for these that we kind of referenced earlier, and that was in your textbook. There's this proportion that we need to look at. So back in 10.2, one of the pages that we looked at was page 532, and we saw this relationship. Okay, this is what we're going to use to set up and solve proportions. So A is degree measure of an arc, but then remember that can also be a central angle because those are the same thing. Here we have 2 pi r. You could also put a c there for circumference. It just depends on what you're trying to find, whether you're working with c or whether you're working with radius. But this is the kind of the proportion that we want here. So I'm going to write that down, and we're going to use that for the last 3 problems here. So A stands for arc measurement or central angle measurement. Then we have 360. So that's got to be equal to the arc length, which they're using L for arc length, over the circumference. So you could put a C here for circumference if you're trying to find circumference. If you're talking about finding R, you're trying to find R, then you should probably put 2 pi r down there. So I'm going to put or C because it could be a C as well. So think about this. This is the degree side, right? So I'm going to label this. This is the degree side. And this is the unit side, right? We're talking about centimeters or feet or miles or whatever it happens to be. So that's what these measurements are. But on the top we have the part, right? An arc measure is part of a full circle, or a central angle is part of a full circle, but it's in degrees. And then we have the full circle, which is whole. Okay, over here we have a length, an arc length, which is part of a full circle, over its circumference, which is the whole of the full circle. Okay, so let's kind of draw that out really quick and describe that. Okay, if this was let's say 30 degrees, then I have part of the full circle measure, 30, over the full 360, right? But if I also have an arc length, now of course this is 30 degrees, right? We know that, but you could also label this with an actual unit. I could say, let's say this was 15 pi centimeters. Okay, well now we're talking about units, so 15 pi centimeters over the full circumference, 2 pi r, is going to have to be on this side. So part to whole, this is the degree side, this is the unit side, but they have to be equal ratios. They have to be proportional. Okay, let's take a look at 15. In a circle with a circumference of 18 pi, there is an arc that has a length of 3 pi. What is the measure of the central angle that defines the arc? Okay, now remember, central angle and arc measure are the same thing. Okay, so let's use those guys and set up a proportion. Okay, circumference is 18 pi. So this is 15. Okay, that goes on the bottom, down here on the right. Right, circumference is down here. This looks like it says arc. Sorry, it doesn't say arc. It says or C. C for circumference. Just want to be clear there. So I put the circumference down on the bottom right. Okay, the arc length, L, is 3 pi. Okay, what is the measure of the central angle? Well, remember, central angle or arc measure are the same thing, so I don't know what this is. Okay, but I do know the full circle is 360. So that's what's going on here. I need to find the angle. If we want to draw a picture, we can do that. Okay, so here I have, I don't know if this is how it looks, but whatever. This arc length, not the arc measurement, not in degrees, in inches or centimeters or whatever. Let's say this is 3 pi, and let's say it's 3 pi centimeters, just so we don't get confused. This is not degrees. That's this guy. Now the full thing all the way around is 18 pi centimeters. Okay, so I have those on the right. 3 pi over 18 should equal whatever this angle measurement is over the full 360. Okay? Now, of course, this angle measurement is going to be the same as this arc measurement. But remember, arc measurement is in degrees, whereas arc length is in, centimeters or something like that. So the angle in degrees, or the arc measure in degrees, those will be the same, over 360 is equal to the arc length over the full length. Okay, so don't want to beat a dead horse. I just want to be clear. So let's solve this proportion. We'll start by simplifying. Okay, pi over pi cancels, so that's kind of nice. 3 over 18 simplifies to 1 over 6. All we need to do now is cross multiply and solve. So a times 6 is 6a, and 360 times 1 is equal to 360. Okay, let's divide both sides by 6, and we're going to get a is equal to 60 degrees. Okay, so that a is either the central angle, 60 degrees, or the arc measurement. So for this guy, the arc measurement is 60 degrees, and the arc length is 3 pi centimeters. Remember, those are two different things. We're trying to find the arc measurement in degrees. All right, let's do one more. Let's look at 17. Okay, number 17, I'll just read it. Well, here we go. Consider an arc with a degree measure of 216 degrees. Okay, so this is capital A. Okay, that's the arc measurement. Now it has a length of 48 pi. That's L. What is the radius of the circle that contains the arc? All right, let's set this guy up. So I'm using this same thing. Okay, A over 360, but this time they gave me the arc measurement. Okay, so 216 over 360, so A over 360, equals, we want L over C or L over 2 pi r, depending on what we're trying to find. So I could write L over C. But since we're trying to find radius, instead of writing C, I'm thinking I'm going to write 2 pi r because I actually want to find out what r is. So this is my setup. I'm going to cancel where I can, and then I'm going, oh, sorry, we actually know L. This is L, but they gave us L. It was 48 pi. Okay, so I'm going to cancel where I can, and then I'm going to simplify, cross multiply, all that kind of stuff. Okay, so pi and pi cancel, that's great. 48 over 2, okay, that simplifies to 24 over 1, but remember there's an r down there. So now this is 24 over r, okay. 216 over 360 I think will simplify as well. Definitely 2 goes into both of them. Okay, so this actually simplifies way down to 3/5. And now we can solve this by cross multiplying. So 3r equals 5 times 24. I think that's 120. Just double checking here. Yep. Okay, divide by 3, and that's r equals 40. Sorry, you guys lost track of me there. Let me show you what I did. So I cross multiplied, right? 3r, and then 5 times 24 is 120. So that gave me this. 3r equals 120 from cross multiplying. Okay, then I divided both sides by 3 because I wanted to cancel out the 3, and I got r is equal to 40. And since we're talking about the radius, that's not a degree measurement, that's some unit. I don't think I told you if it was like centimeters or inches or whatever, so we'll just go r equals 40 units. All right, so that is how it's done. So that's more than half of the problems here. I think that will get you started, give you some ideas. You guys can come back and finish the evens, and we'll see you back in class. Hope you have a really good 3-day weekend.